Hi class. In this video we'll start talking about Newton's laws and I will go through the first two. So you may or may not know that the first of Newton's law is inertia. And inertia really is about the object's tendency to retain motion. That is, if you have a block or something on a table and it's not moving, its tendency is not to start moving on its own. Same thing about moving objects. If you have, big truck, loaded freight truck that is moving at some speed v, it's very hard to stop this truck from moving because it has the tendency to keep on wanting to move. Now, these things may be lost in our daily lives, but this would be very apparent in space. So in space, if you have an object of mass m, and that object has a velocity v, it will have that velocity for a very, 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 very long time. It will just travel on a straight line. And this really is what inertia is. Inertia is object's tendencies of retaining its motion, meaning that whatever velocity it has, that velocity will not change. Now we can quantify how much inertia an object has, and so to quantify inertia, we'll introduce something called mass. That is, mass, the more mass you have, the more an object resists changes in its motion. And I can draw this, I can bring back to this example here. So a loaded truck will be much harder to stop than, let's say, a tiny car, right? Loaded truck has a lot more mass, meaning that it will resist changing its motion a lot more. All right, so you have heard me talk about this mass term before. So if you remember, we had a length and we had time, and we used these to describe motion. Meaning length and time was everything we needed to do, everything we needed to build the kinematics, which is a framework to just describe motion. Here, since we are now talking about inertia, to build Newton's second law, we have to include this idea of inertia in a way that we can quantify it, which is why we introduce mass. Now, mass is there's a couple different units for mass. The one we are going to use in this class is the kilogram, which is also 1,000 grams. And one that's commonly used in the United States is the pound. So some of you may be much more familiar with the pound rather than something like the kilogram. Okay? Right. So now, this is Newton's first law. It's inertia. And the second law is more or less a continuation of it. And it describes, it models how, if a motion is to change, how can you quantify that change? So let's think about what changes is. So if you have something going a straight line, it has some velocity v. As long as it has a velocity v, the motion is unchanging. and then if something ought to happen to it, and now it has a velocity this way, at this point here there was a change in that velocity, implying an acceleration. So we're borrowing the concept of acceleration to describe a change. So this describes a change in the motion state of an object. In inertia is how much an object resists this change, mass. So now we can build a quantity. We can say that whatever this quantity ought to be here, it needs to make a mass change its motion in some direction. And we'll call this quantity here a force. Mathematically speaking, a force is what makes a mass change its motion state. So for something in which the motion state does not change, the force is zero. And it is this equality that is the second law. And in words, it means that a object is if you combine the second and the first law, the motion of an object will not change unless a force here acts on it. Okay, so let me go ahead and do a quick example here of a calculation that you will encounter. So let's say you have a car, and this car is accelerating this way. The acceleration is 2 meters per second squared in the plus x direction. So if we call this the plus x, that's where it's accelerating. And the mass of this object is 5,000 kilograms. Okay, so if you want to go ahead and practice, go ahead and tell me what is the force that must be acting on this object along the x-axis to cause this acceleration. Force equals to what? So pause the video, see if you can get it done. Okay? So first thing we do is we state our working equation. Forces equals to mass times acceleration. I already said that the acceleration is 2 meters per second squared in the plus x direction, and the mass is 5,000, so it's just a matter of plugging in the numbers here. So this is 5,000 kilograms multiplied by 2 meters per second squared in the plus x direction. And since force is a vector, you do have to include the direction. So this is 10,000. Now the units is kilograms meters per second squared in the plus x direction. This here is a very special unit. We use it so often. The concept of force has become so useful that it has its own unit, and we'll call this a Newton. So 1 Newton is 1 kilogram meter per second squared, and it is a mass, a length over a time squared. And you can work that out if you remember that this comes from the acceleration part and this comes from the mass part. Okay? Good. And so that's a simple force calculation. And the second example I want to show you is something like gravity. So if you remember from kinematics, we worked that it doesn't matter if an object is big, so having a big mass or a little mass. If you're near the surface of the Earth, both of these objects will experience an acceleration, which is a 10 meters per second squared downward, right? So if I call this the y direction, I can say that this is in the minus y direction, okay? So remember, this was defined as an acceleration. Now we can define a gravitational force now, and the way we do that is that to say that a gravitational force equals to the mass times the acceleration of gravity. This also has a very special name in physics. It is called the weight of an object. So the weight is the mass of an object multiplied by the acceleration of gravity, and that's also called in physics the gravitational force. In this case, it's a gravitational force at the surface of the Earth. There is a more general version of this that we will not see in this class. But what I want to emphasize is that, colloquially speaking, people tend to call weight, associate weight with mass. In this class, we will associate mass with inertia. So mass gets tied to inertia, and it is quantified in kilograms. And a weight is a force, and is quantified by newtons. Or it's quantified by, it is a force, quantified by a force, is expressed as a newton. Okay, so this concludes my introduction to Newton's laws. Later on, we'll see the third law and how that plays into friction. Have a very good day, and I'll talk to you all very soon.